Altimetry satellites tell us precisely how climate change is impacting rising sea level.
Satellites have been precisely measuring the rise in sea level since 1993, with TOPEX and then JASON-1 and JASON-2, soon to be joined by JASON-3. These satellites are capable of estimating sea level with an accuracy of around 0.6 millimeters a year, and they're telling us it's risen at a rate of 3.2 millimeters a year since 1993.
The global picture that satellites offer is a key advantage over point tide gauge readings.
With satellites, we obtain a picture of regional variations in sea level. In other words, we see that sea level isn't rising uniformly, but faster in some parts of the globe than others. In the Western Pacific, it's risen by up to 10 or 11 millimeters a year over the last 20 years, while in other regions, like the west coast of America, it's risen very little, and in fact fallen at a rate of 0.5 millimeters a year.
4 factors are at work: expansion of warming water, melting of the polar ice caps, melting of continental glaciers, and the influx of surface waters.
Sea level rise hasn't accelerated since we started observing it with satellites in 1993. On the other hand, if we look for a longer period over the 20th century, tide gauge measurements indicate that before 1990 sea level rose more slowly, at a rate of 1.7 millimeters a year. It started to rise faster from the end of the 1980s.
Predictions for the 21st century are more ominous.
One of the reasons sea level is now rising, the main reason in fact, is greenhouse gas emissions. In the future, we expect these emissions to increase, and so sea level will rise faster. By the end of the 21st century, we expect sea level to be between 25 and 95 centimetres higher than it is today. That's a broad range of values factoring in all of the uncertainties regarding climate predictions for the end of the 21st century. There are uncertainties about future greenhouse gas emission scenarios, in how sea level is modelled in climate models, and uncertainties due to the chaotic nature of Earth's climate system.
Continuous monitoring by satellites is therefore vital to gauge future sea level rise, define regions at risk, and anticipate disasters.